Good day, mates. Today we are going to go on an adventure with an Australian family, with a man named Vector and his daughter Luna, and his wife, and we're going to solve inequalities. iReady lesson, solving inequalities. Let's begin.
Wow! Watch out, Mags! There are ships coming at us from all directions!
Oh my goodness, this is just crazy.
Umi says that high-speed space travel grew so fast that they didn't have a chance to develop any kind of highway system. He could use our help.
Alrighty, let's help them out. Where should we start?
He wants to create an intergalactic transportation system that will bring relief to the heavy flow of traffic.
That sounds like an awful lot of work.
Don't worry, Mom. He only needs us to plan just one of the routes. First, we have to find a way of organizing the passengers.
Where should we start?
The most popular place on our route is the planet Inequalities.
We will need 2 vessels, one to travel in each direction.
What, Umi? We need to use the universal language of algebra? Okay, let's get to work.
Crikey, that sure is exciting.
Okay, let's start by separating the passengers. We know we have 2 directions. Those going with stops that are less than or equal to 5 Jarmex will take a ride on the Flying Zookman.
And those who are going to a stop that is greater than or equal to 5 Jarmex will cruise along the Whirly Sail.
Twiggle's stop is at 3 Jarmex, so he will need to board the Flying Zookman. Click on the Flying Zookman.
Wait, what does algebra have to do with this?
You see, sweetie, the aliens can substitute the value of their stop for X, and if the inequality is true, they know they are boarding the correct ship.
Oh, I see. 3 is less than or equal to 5, but 3 is not greater than or equal to 5.
So Twiggles is gonna soar on the Flying Zookman. Now it's your turn. Place Splat on the correct spaceship.
Okay, so we need to think. -2 is here and here. We need to think which spaceship they're going to be on. We know that -2 is less than 5, so we want to put him on the Flying Zookman right here. And remember our little hint, whichever way the arrow is pointing, that's the way the numbers are. So we want this one because the numbers are going to the left. If we had a number that was larger than 5, we would put it on the Whirly Sail because those numbers are over here.
That's right. -2 is less than 5, so Splat should ride the Flying Zookman.
Yay.
Which vessel should Felisa board?
Okay, so now we have 6. We know that 6 is going to be larger than 5, so that's on this side. So we want the Whirly Sail. So we're going to put our 6 right here.
All aboard! Woohoo! 6 is greater than 5, so Felisa should board the Whirly Sail.
What about Kusif?
Okay, we know that 1.5 is less than 5. We know that numbers less than 5 are going up here. So we have 1.5. We're going to put it in between our 1 and our 2.
That's right. 1.5 is less than 5. So Kusif should ride on the Flying Zookman.
Which ship shall Kublik board?
Okay, so we have 7. We know that 7 is larger than 5. And we know that our numbers larger than 5 are going on the Whirly Sail.
Absolutely. 7 is greater than 5, so Kublik should hop on board the Whirly Sail.
The Whirly Sail.
How about rock roll?
Okay, 5.5 is still larger than 5. So we're going to go right here in between the 5 and the 6 on the Whirly Sail.
Rolling right along. 5.5 is greater than 5, so rock roll should roll right on the Whirly Sail.
Rolling along, because his name's Rock Roll.
Don't forget about Heptoculus.
What a name. Okay, 4.5. That number is less than 5. Less than 5 goes up here on the flying Zuckman, right in between 4 and 5.
That's right. 4.5 is less than 5.
Teamwork makes the dream work.
And look, Festivo is at exactly 5 Jarmex.
Okay.
Both vessels make a stop at his home planet.
He can go to
because
either one.
5 is equal to 5.
Look at the number lines. What do you notice about the stops?
Okay, so we notice that all of the stops for the flying Zuckman are on the left of 5. That is true, but they are also on the 5, so it's not completely true. All of the stops for the Worley sail are on the right of the 5. That is true, but not entirely true because they also land on the 5. None of the stops for the Worley sail are on the left side of the 5. That is 100% true because they will never be on the left side of the 5 because they have to be 5 or more. So we're going to click this one.
None of these stars are on the left side of 5.
Moving right along.
That makes sense. We will accept any value less than or equal to 5 for the flying Zuckman.
So there's our nice graph.
And the numbers get smaller as you go to the left.
Right, and look at the arrow. It's
Five,
pointing.
so we will
Oh, you
use
guys are
a
backwards.
dot to show
Pointing
the
to the
cutoff
left.
point.
Right up here.
Opposite is true for the Whirly sail, so we can use an arrow
So
to the
our
right
arrow's gonna
to show
point
that
to the
we
right.
want values greater than or equal to 5.
And we have closed circles on both 5s because we know that it's a less than or equal to symbol and a greater than or equal to symbol. And when we have those symbols, we make sure it's a closed circle to represent that the 5 is included in the solution set.
So, without knowing where all the planets are located, how many possibilities do we have for bus stops on the flying Zuckman?
So because an inequality solution set goes on forever, that's what that arrow means. When we point it, we started on one point and then it points in the opposite direction that we want it to go in. It goes on forever and ever and ever and ever and ever, which means that we have as many stops as we want.
Absolutely. Oakley dokley, we have our algebraic and graphical
We are going to
representations.
start saying
What's
that.
next? Ah, yes, verbal.
Which 4 statements are true?
Oakley dokley. Let's read through them. So first we see that we have x is greater than or equal to 5. So our first one right here is true. We have to click them one at a time. So let's
That's
start.
exactly how you would read this statement.
Exact.
Keep going.
Okay, x is less than or equal to 5. That's not true. That's the complete opposite of the top one. X cannot be less than 5. X cannot be less than 5. That is true. So we're going to select it, submit it.
X is greater than or equal to 5, so it's impossible for it to be less than 5.
Very good.
Keep going.
5 is the smallest number that x can be. Yes, that's true. 5 is the smallest it can be. It has to be 5 or more, so that is true.
None of the numbers that are smaller than 5 are shaded on this number line. So 5 is the smallest number x can be. Keep going.
X is at most 5. That means that the biggest x can be is 5, so that's not true. X is only greater than 5. That's not true because it's greater than 5, but also can be equal to 5. And x is at least 5. At least means the smallest it can be is 5, so that is true.
Saying x is at least 5 is like saying that the lowest value for x is 5. And that is true. Nice job. You found all of them.
Thank you very much.
What's that thing screaming about?
Oh dear,
I think the engine is about to overheat.
that's not good.
What's the temperature now?
Oh dear.
-10.
That's plenty cold enough. Let's double check the settings. According to this ship's manual, the engine will overheat when it reaches -4 degrees flanking cranks.
Let's graph it.
Let's graph it. Magic to my ears.
Crikey, what does that weird-looking dot represent?
Daddy-o, that open circle means that -4 doesn't count. We get as close to it as we want, like -4.000000001, but just not -4. Which symbol should we use to complete the inequality?
So we know that when we have an open circle, it's only going to be a less than symbol or a greater than symbol. Since our arrow is pointing to the left, we know that we're going to have all the numbers less than -4, which is going to be the less than symbol.
Perfect. This open circle means less than but not equal to.
Right.
That's exactly what we want.
So -4 cannot be an answer, but anything less than -4 can be an answer. So like she said, the closest number to -4, that would be in between -4 and -5, would be that -4.00000001. It's super close to -4, but it's still less than -4.
How would you describe this graph?
So t is less than -4.
Exactly. The temperature can be any number smaller than -4, but not including -4.
If the temperature of the engine starts to rise, we will be A-OK as long as it stays below -4 Frankenkreis. And it can get really, really close, it just can't reach it.
And that's why we used an open circle. Okay, I think the engine should be safe with the new limits we put on it.
But are we going to be safe from bad flyers?
Maybe we need to discuss implementing a maximum speed on these routes.
Always a good
I'll
idea.
tell Umi when you two figure this out.
Okay, I think the speed limit should be 27 Jomex per Quelp.
How do we represent this as an inequality?
Okay, so the limit is 27. So that means that we can't go higher than 27. We can go 27. So we want 27 or less, which means V has to be less than or equal to 27.
That's it! You can fly exactly 27 Jarmex per Quelp without speeding, or even slower. So we need the less than or equal to symbol.
The velocity limit should be 27 Jomex per Quelp. Then the Galaxy Police can give out tickets to anyone who goes over the limit. Let's make a graph. Drag and drop the correct circle to its place on the number line.
So we know we want a closed circle because it's 27 or less. And now we know we want it to point to the
Which direction should the graph go?
left because we want all the numbers that are smaller than 27.
That's one nice looking graph.
Thank you.
Hey, Dad, can we go -10 Jarmex per Quelp?
Sure thing. Just
extremely
pop
slow.
that puppy in reverse.
You kids, get off my blard. That's my impression of Grandpa Goopy. He's worried about having to travel across the universe with a bunch of young'uns running around. Is there anything we can do to calm him down?
Why don't we dedicate one area of the ship for older aliens only?
Luna, honey, I think you meant to say the chronologically gifted aliens.
On my planet, you are not considered to be, chronologically gifted until your 250th birthday.
Oh, my Lord.
Then it's settled. We will have an older than 250 Doblas section of the ship.
Cute.
Make a graph that will represent the inequality.
Okay, so we know it's going to be an open circle because we have greater than. So 250, there's our open circle. And we know that we are going to point to the right because they have to be 251 or older. So we want this way to the right. Hit the check.
Nice graphing.
Thank you.
How would you describe this inequality?
Okay, so A is greater than 250, which means that 250 is less than A. Tried to flip it around and trick us, but it didn't work.
I see the reversed order did not throw you off.
No, sir.
Good job. Inequalities can always be rewritten, but you have to be careful when switching things around. When we move the numbers, we have to make sure the symbol is switched too.
We need to make sure that the inequalities are still representing the same idea. A is greater than 250 is the same as 250 is less than A.
We could always use substitution to check.
Good idea, sweetie.
Love
What if
substitution.
A equals 300?
It works. Any value for A that would make a true statement on the left would also make a true statement on the right.
Now remember what we said. In order for our arrow trick to work, the variable must be on the left-hand side. If your inequality is given to you and looks like this, we need to rewrite it if we want to use the arrow trick. Otherwise, we just have to think logically about what it means. Once we flip it, what I always do is I think back to like second grade when we first learned how to compare numbers. See how the opening is like the mouth is eating the A? That means that when it's on this side, we also want the mouth to eat the A. So we're flipping the inequality symbol. So this is not to be confused when we multiply and divide both sides of an inequality by a negative number and we have to flip the inequality symbol. This is just strictly rewriting the inequality to mean the exact same thing going forwards or backwards. Okay?
I think we worked out all the details, and look, we have arrived at planet Alata Partis.
Let's find Festivo and get this party started.
You are so immature, Dad.
So much.
Come on, guys. The first game is about to start.
We're coming.
How do you play this game?
I don't know, but I get to go first. Roll, baby, roll. Okay, I got a 2. Your turn, Dad.
Come on, Daddy needs a new pair of boots. Looks like I got a 4. I hope that's good.
Yee-hee, I wonder how high this die can go.
Your turn. Click the die to roll it.
Here we go.
Looks like you got a 10.
A 10.
Oh, look, an inequality. Let's see which numbers will work.
So much fun.
Sort each player's roll so we can see how we did.
Okay, I'm going to pull up the little notepad over here. All right, let's just leave it here for now, and we'll close it. And I'm going to try typing to see if that's a little neater and faster. Okay, so we have Q plus 4 less than 12. All right, now we're going to substitute in. So let's do Luna first. So Luna is 2. So instead of Q, we're going to have 2 plus 4 less than 12. Now we're going to combine our like terms. 2 plus 4, 4, 5, 6, 6 less than 12. That is true. 6 is less than 12. I'm going to close my notepad. So Luna makes inequality true.
6 is less than 12.
Perfect.
True.
Great. Let's do the next one. Notepad, where are you? All right, let's move it down a little bit. That's fine. Whatever. All right. So can I delete this? Yes. All right. Again, we had Q plus 4 less than 12. We're going to do vector now. So 4 plus 4 less than 12. 4 plus 4 is 8. 8 again is less than 12. Let's close that and put vector over here because that is true. 8 is less than 12.
8 is less than 12. True.
All right, next we're going to do mags. So mags is 8. So 8 plus 4 less than 12. Now, we know that 8 plus 4 is 12. So we have to think to ourselves, is 12 less than 12? No. So that's not true. So mags is not true.
12 is not less than 12. It is exactly equal. This is not true.
Okay. And now we're going to go, and we are 10. So 10 plus 4 less than 12. 10 plus 4, 14 less than 12. 14 is not less than 12. 14 is greater than 12. So we also make the inequality not true.
14 is not less than 12. This is not true.
No. Q plus 4 must be less than 12 to ride the swirlometer. Well, we can't ride it. Darn.
Looks like Luna and Vector get to ride on the swirlometer.
Shucks.
Awesome. I
Maybe
wonder what
next
happens
time.
in the next round.
Well, let's see. I got 40 this time.
And I got a 20.
50 for me. What about you?
Well, let's see.
All right, let's see what happens.
Interesting. Sort each player's roll so we can see how we did. All right, we have a new inequality. I want to pull up my notepad. All right, I have a greater than or equal to symbol. So we're going to do the best that we can. 2r minus 1 greater than or equal to 100. We're going to skip a space so that we can draw the line after. So Luna is 20, so we're going to substitute 20 in here. Greater than, minus 1, greater than or equal to 100. Now, 2 times 20, we're going to combine like terms. That's 40 minus 1, greater than or equal to 100. 40 minus 1 is 39. 39 is not greater than or equal to 100. Now, oh my gosh, look at this beautiful blue color. Oh, this is so exciting. Okay, I'm drawing the little mini equal sign underneath so that we see this a tiny little bit better. All right, so 39 is not greater than or equal to 100. Let's close this. So Luna does not make this inequality true. There's our work. Okay, pull up our notepad again, and let's use the same work and just substitute in. So we have the same inequality. Vector is 40, so we're going to delete this stuff. And instead of 20, we're going to substitute in 40. So now we have 2 times 40 minus 1. Yeah, that moved my line. Okay, let's combine like terms. 2 times 40 is, everybody all at once, 80. Now we have 80 minus 1. 80 minus 1 is 79. 79 is not greater than or equal to 100. So vector does not make this true. And there's our work. Match the same. Pull up our notepad. We're going to delete this and we're going to delete this. Everything else is going to stay the same. Mags is 50. So instead of substituting in 40, we're substituting in 50. Combine like terms. 2 times 50 is going to give us 100. So we're going to have 100. Everything else is coming straight down. So now my little, I don't have an eraser. Okay, well, pretend our line is over here. This is our line. That's a terrible line. Just pretend. So now we have 100 minus 1. 100 minus 1 is 99. 99 is not greater than or equal to 100. So Mags also does not make this true. There's our work. Now, let's see. We're going to pull up our notepad. We're substituting in 60 for us. 2 times 60 is 120. 120 minus 1 is 119. Okay, so now we do make it true. And there's our work.
No, it looks like the 3 of us didn't make it out of the slime zone.
Ew, gross.
Slime.
This certainly is an interesting game. Come on, honey. You only live once.
YOLO! Let's see what the final round has to bring us.
YOLO.
That's weird. A negative number.
So weird.
I got an even bigger negative number. Wait, or is it smaller?
It is.
What do you know, Vic? I guess opposites do attract. Your turn.
Opposites attract. You guys get it? Because they're additive inverses. They're opposites on the number line. And they're husband and wife, so opposites attract. Oh, and we are opposites with Luna. How nice. Okay, sort each player's role so we can see how we did. We don't have to do any work here. We just have to think. We have P less than or equal to negative 4. Negative 20 would be on this side of negative 4. So negative 4 is greater than negative 20. That makes it true. There's our negative 4. There's our negative 20. We're good to go. -2 is not less than -4. -2 is bigger than -4. If you think about it, -2 would be over here on our number line. So vector is not true. There we go, -4 and -2. Mags is +2. So mags is going even more to the right. So mags is also not true. See? We're going more to the right. And now we're +20, so we're even further to the right. So we're also not true. So Luna's the only one who makes it true.
All of the parties take place on floor -4 and below.
Oh, shucks.
Looks like only one of you will have access.
Snickle Fritz. Can't go to the dance party.
But we all came here to join in the festivities.
Yeah, we want to have
You
fun.
didn't let me finish.
Sorry.
Only one of you will have access for free.
Oh.
The rest of you will have to earn your way by showing off some super sweet dance moves.
Typical.
We have some tricks up our sleeves that will knock your socks off.
Yeah, we do, Mags.
Show us to the dance floor.
To the dance floor.
You guys are so embarrassing.
Thank you. All right, let's go take the quiz.
Which graph shows the solutions to the inequality?
Well, we see that we have n less than or equal to 46. We know we have a less than or equal to symbol, so we want a closed circle, so either the first or the last for us. And we see that our variable is on the left. That's good. We can use our arrow trick. So we want all the numbers to the left. So we're going to select this one right here and done.
Which graph shows the solutions to the inequality?
Okay, p greater than or equal to -1. So closed circle. Oh man, they're all closed circles. We know we need to start at -1. So these first two are, well, this first one's out and the last one's out because they're both +1. So we want one of the middle ones. Now we just have to figure out which way we want the arrow to point. We see that p's on the left, so that's good. Our arrow trick works, and we want the numbers that are pointing to the right because our arrow would be this way. So right here, this choice, we want all the numbers larger than -1. Done.
Which inequality represents the graph below?
Open circle, so we know we want either less than or greater than. And we're talking about all the numbers to the left of 5. So those are going to be all the numbers that are less than 5. So right here, Q is less than 5.
Which inequality represents the graph below?
Okay, we have a closed circle. So we know it's going to be one of these two choices. We want greater than or equal to or less than or equal to. We know it's 2.5. That's good. And we see that it's pointing to the right, which means it's all the numbers larger than 2.5. So we want greater than or equal to 2.5.
Which inequality represents the graph below?
We have a closed circle, so we know it's going to be one of these two. We see that it's pointing to the left, so we want all the numbers that are less than 75. So right here.
Click on the value for m that makes this inequality true.
So now we could do a guess and check, or we can do what I'm going to do, pull up our handy dandy notepad, and we're going to break this down. So we have 3m plus 10, let's see, less than 30. Okay, now I'm going to switch over to my beautiful colors. I'm going to use this one to draw my line. Remember, we solve these like a regular equation. Now, we want to get our m alone. So first, we have to subtract our 10. Minus 10. Minus 10. So 30 minus 10 is going to give us 20. Remember, these cancel out. Bring down our 3m. Bring down our inequality symbol. And our 20. Okay, now we are going to divide both sides by 3 to get m alone. Okay, now this is not going to be the prettiest number in the world, but that's okay. We know that 3 goes into 20 6 times with 2 left over. So what that tells us is that m has to be less than 6 2/3. So we're looking for 6 or less. So now let's close this and look at our answer choices. Remember, we want 6 or less. And right here, we see that 5 is an option. Now let's just double check to make sure. 3 times 5 would be 15. 15 plus 10 would be 25. And 25 is less than 30. So we're good. Okay,
Click on the
same
value
thing.
for n that makes this inequality true.
All right, I'm going to pull up our notepad. Let's see if we can undo all of this and type this guy out again. Okay, so here we go. We have 120 greater than or equal to 10n plus 20. All right, let's switch over. So first we want to make our symbol the same. And now we're going to draw our line to split it. We have to subtract 20 from both sides. So minus 20, minus 20. We know that our 20s are going to cancel out. So bye-bye. Everything on this side we're going to bring straight down. So we have 10n. We're going to bring our inequality symbol down. And we're going to subtract 120 minus 20 gives us 100. Now we're going to divide both sides by 10. These will cancel, and we will have n. Bring down the same inequality symbol. 100 divided by 10 is 10. So now what this tells us is 10 is greater than or equal to n. Or this can be rewritten as n. Remember, we want to switch it around so the variable's on the left. Now remember the little trick. The mouth is open to the 10. So we want the mouth, again, to be open to the 10 when we rewrite it. So n is less than or equal to 10. So we know we can have 10 or any number less than 10. So let's look here. We have 10. Nothing else is less than 10, so that's the one we must want. And very good. And let's just double check. So 10 times 10 would be 100. 100 plus 20, 120. And 120 is equal to 120. Good to go.
Click on the value for p that makes this inequality true.
I'm going to delete this while he reads it to us. Or he's not going to read it to us, that's fine. So we have p greater than or equal to negative 12. We actually don't have to do this for this. We can just substitute it in by choice. Negative 13 is not bigger than negative 12. 0 is bigger than negative 12. So right here, we see that that's our answer because all of these numbers are going to be further to the left of the negative 12, which do not make it true. So we're good. And there we go. We're all done. All right, make sure you complete your iReady video called Solving Inequalities. Have fun.